Okay, so here we have the previous examples we just calculated and drew the electronic configurations for. And we're going to take these configurations now and try to evaluate for each of these four elements something known as valency. And valency is essentially a number that we can use to help us work out the formulae of compounds that are formed when these substances react with each other. And valency is essentially the number of electrons which are either required or required to be lost, so either gained or lost, in order for an atom to get to the closest possible situation whereby each of the electron shells are filled completely. So if we look at sodium's case, the first two shells are completely full. And so the easiest way for this to get to a complete shell situation is to lose that one outer electron. Likewise, for magnesium, the easiest way for it to lose two electrons is the quickest way for it to get to complete outer shells by losing that outer shell. Likewise with lithium, that can lose that one outer electron and get to a complete shell. Remember, for the first shell, only 2 electrons are required compared to the 8 for the second one. So this gives rise to the valency becoming a number, and for sodium, it is literally the number of electrons that are required to be lost. For magnesium, it will be 2, and lithium, it will be 1. Again, coincidentally, but not really, it is again the group number and the number of outer shell electrons. So we're seeing these numbers repeatedly. Now, for a non-metal, so oxygen, something towards the right-hand side of the periodic table, the easiest way for it to get to a full outer shell is now not to lose the 6, but to gain 2. So if it were to gain 2 electrons, it will get to a complete outer shell octet. But in the same way, its valency becomes number 2. So obviously 6 going to 8 requires 2 electrons. So there's a relatively simple bit of arithmetic to get to the valency. But we have a quick fire way there of using the group number. So anything in group 1 will have a valency of 1 because it wants to lose that one outer electron. Something in group 2, want to lose 2, has a valency of 2. Something in group 3, 3, etc. Something in group 7, for example, would only have one space, would only require 1 electron. So also, similar to group 1, would also have a valency of 1. Whether or not they are gaining the electrons or losing the electrons doesn't change the valency number. Okay, it's just a numerical value, either 1, 2, 3, or 4 for the simple elements, definitely up to calcium. And what we're going to do in the next clip is look at how we then combine valency for 2 joining elements in binary compounds and how the valency can help us to evaluate what the resultant formula of the compound will be after reaction.